The overarching goal of my work is to really look at the fire environment from an energy perspective. The particular project that I've been working on lately is looking at fuel break effectiveness. The Fire Lab has the unique ability to do a lot of testing in a controlled environment, and this research started out in that format. We leveraged our wind tunnel and our burn chamber to do a series of experiments under a controlled setting. The tallgrass prairie created that homogeneous landscape to expand our lab experiments to the field to see how well what we captured in the lab setting could be replicated in the field setting. We don't have that same control in the field, so it's really critical that we know what the weather and winds are doing. And so we set up remote weather stations, much like the one behind me, which gives us wind speed and direction. Our group has been able to build a series of in-fire sensors. We call them fire behavior packages, or FBPs. And we have a data logger inside of it with a battery system on the back. Everything is very sensitive, so we have to wrap them. We passionately call them bling, but it's just, it's an insulated little fire shelter packet where the sensors are still exposed, but they give us the ability to protect it in a very austere environment that we have in fire research. We can set these in a variety of setups to give us sort of that fire behavior on the landscape. And everything's time synced between our fire behavior packages, our cameras, and our weather stations, so that when we see heat arriving, we know what the winds are doing. Lately, we've added a drone to this same sort of experimental setup. And so what we noticed and what we found in the past is like our data is only as good as the number of packages we have out. We get point source data wherever we have a fire behavior package or a camera box. And then you just sort of extrapolate to what the landscape sees based on the data that we collected. So by getting an infrared camera airborne gives us that landscape scale so we can see the ignition and we can see the spread, and especially in this fuel break project, we can see when fire hits a fuel break and we can see the changing fire behavior associated with that, and really helps us to identify like where the strengths and weaknesses are in the data that we've collected. And so to couple that fire behavior package with a camera really helps to tease out the data when it's not obvious. It's been a game changer for us. We were experts with in situ data collection, but really coupling it with the UAS drone infrared really provides this landscape approach to effectiveness, fuel break effectiveness in this particular case.